Hello, everybody. I hope you're doing quite well and you're staying safe and happy. Well, this is the second video in the series of my difference between that we worked out. So, as you have noticed, the first video was basically on proportionality and equality. Well, this is a video which would be useful for those who are starting their career or understanding what is calculus. So, you might come across this type of notations, which is quite frequent in mathematics of calculus. That's what we come across what is d by dx. We also come across what is dy by dx. Okay, and we use this term, the d by dx. You will see in my next videos where I have shown examples of differential rules. So we have used this particular notation d by dx. So I think this is the right time that we should start understanding what is the difference between these two parts, that is what is d by dx and what is dy by dx, what actually it is. So I hope this video will come to use. So it's a good time to start to learn the differences between the two. So just to start with the notation, I will just like to tell you that when we say for example, I would just like to write it here, like when we say dy by dx, right? So when we use this typical notation, so what we are trying to tell over here, this means that we are differentiating. This means the derivative of y with respect to x. So I can write this as, let me just abbreviate it, derivative of y with respect to x. Right. So dy by dx actually means it is the derivative of y with respect to x. Now, as we have noticed earlier, that if we use this particular part, like we use y equals to fx, if this is a particular function, then as we have seen, y equal to fx is a function of x, then definitely what we can do is that we can write, as we have noted in the earlier notation, dy by dx of limit of h tending towards 0, and as in the numerator we have seen f equals to x plus h minus f of x whole divided by h. So this is the particular notation which we have seen earlier. So when we say, or rather when we use this notation dy by dx, what we are trying to tell is that derivative of y with respect to x. This part is called the derivative of y with respect to x. Now please note that dy by dx, okay, doesn't have a meaning, or it is not a division that you are dividing something by something. We take dy by dx as a symbol. Okay, now this particular part, dy by dx, can be further divided into, say for example, d by dx. So this particular part can be written as there. And this one, the difference is that this is considered to be an operator. We will soon see certain examples. This is an operator. Operator in the sense, just like any mathematical operator, plus, minus, addition, subtraction, division, multiplication. So this particular part is the operator. So we can apply this operator, this particular operator, to any differentiable function, right? And we get a new function. So if, say for example, if f, let me write it over here. If I consider, for example, f, this f is a differentiable function, so we can apply d by dx, and we write, if we use this one, then what we do is that we can write d by dx f. So what we are doing over here is that we are using the operator d by dx as an operator in the function, and we are writing this. So if we write something like y equals to fx, okay, we are writing y equals to fx, then this part, it is similar to if I write d by dx y, and similarly we are using this equal to dy by dx, right? So d by dx, let me show it here. So now you see this one, d by dx means differentiate. Okay, let me summarize it so it will be easier for you. We use a different pen. So what we can write is that d by dx, this means differentiate with respect to x, okay, d by dx means differentiate with respect to x, whereas if I write dy by dx, this means differentiate with respect to differentiate y with respect to x. But this would also mean I would write it here, differentiate y. So now you see the difference. This one just means differentiate with respect to x, whereas this part actually means differentiate y with respect to x. So in other words, what we can say is that, say for example, if I further write y equals to f of x, which is a function. So here, let me use a different pen. So here what happens is that this y, right, this is a dependent variable. So I can write this as dependent variable, right? So where y is the dependent variable and x is the independent variable. So this one is the independent variable, right? So this part is the dependent variable when I am writing y equal to fx, and this is the dependent variable. Now dy by dx here actually means differentiate the equation y with respect to x, and d by dx means differentiate with respect to x. Okay, now I will just show you some simple examples which will make things clearer. Now say for example, if I have a say kind of an equation which says y equals to x cube plus 4x squared, right? This is something, right? So what happens is that we can see over here, we sometimes see this part also. So we'll just put a bar over here. So what I'm trying to tell is that we see d by dx of x cube plus 4x squared. We see this part also, right? So, and we also see like dy by dx, what it is, d by dx, right? So d by dx, I will just write it here. So the further, in order to know further what you can understand, when I say d by dx, it actually expresses a command. It expresses a command. That means, say for example, it is a verb. So here it is saying that find the derivative of x cube plus 4x squared, right? When I am writing d by dx, that means it is telling me something to do. Whereas if I write dy by dx, right? When I write dy by dx, it tells you that this is the derivative of some function x, y, whatever, right? So if I take a dy by dx, now let us do it. I hope those who have gone through the basic rules of calculus can understand. Now, when I say for example, I'm finding dy by dx of this particular equation. So I write it as dy by dx. So I write it as y equals to x cube plus 4x squared. And if I'm differentiating it, what I will get, therefore I will get dy by dx equals to, we know how it happens. So this 3 comes forward and 3 on the top minus 1. And then we get a plus sign, and then we get 2 multiplied by 4 times x. Further solving it, this one we get as 3x squared plus 8x, right? So we get this. This is by dy by dx. If I take a similar kind of an example and if I solve this part by d by dx, x cube plus 4x squared, right? So we also get the same thing. We get 3x squared plus 8x, right? So d by dx tells what to do. What to do? Differentiate the function x cube plus 4x squared, right? So, and dy by dx is basically a statement. That means it shows the derivative with respect to x is this one, right? So in this case, what I can do is that we can further write, let me use a fresh paper for this. So from here, what we can do is that we can therefore summarize, or we can write it over here. So we can write over here, I think it is visible now. So therefore, I can use dy by dx equals to d by dx, right, of y, which in terms can be equal to d by dx, okay, and which one is the previous equation that we just went through, x cube plus 4x squared, right, this part, right, and this is equal to 3x squared plus 8x. So this summarizes in a nice way. I hope this is clear, much clearer. So dy by dx equals to d by dx, right, which is the y variable, and then d by dx of this one will be equal to 3x squared plus 8x. Now say for example, I will let us take another example. And what if we want to find the d by dx, say for example, if you want to find d by dx of x cube. Okay, so we want to find the d by dx of x cube. So we know by the power rule this would be equals to 3x squared, right? So d by dx of x cube with respect to x using the power rule, we'd get this, right? So again, say for example, if I so d by dx comes to so if I take, say for example, another derivative, this is one, part one, this is one, and then what we do is that we find d by dx of, say, y cube. Okay, so what it would be, we know by the power rule that it becomes 3y squared, right? Now see, what is happening over here is that when we found the derivative of x cube, this part and this part is matching. But when we found this part, right, so you see this part and this part is not matching. You see this is x and this is y. This won't be, it would be this one. So sorry, yeah. So this part and this part are matching with variables, but this one is x and this one is y, right? So what we are going to do is that, when we find over here, we found another variable, we write it as dy by dx. Okay, so this is something, this part is something which we call it as implicit differentiation. Right. So this is something which we call it as an implicit differentiation. So when we are trying to understand the difference between dy by dx and d by dx, another important part which comes forward is one which is called, let me write those terminologies for you, it will become easier. One which we called is as explicit differentiation, okay, and another one which is called implicit differentiation. Now, so for example, normal differentiation where the value of y is something like that, I will just show you. If I write y equal to s squared, say for example, so what we find, the dy by dx right? We find it as 2s by the rule, right? So, but if a factor is not written as y, this is actually written, you get the value of y. But what if it is not written as y? So it is something implicitly written. Say for example, if I draw, say x squared plus y squared equals to something, okay, or say x squared minus y squared plus this equals to something. So here what you see is that this is a kind of an implicit differentiation. So differentiating the explicit means where the differentiation value of y is given. We will see further examples where the value of y is given. But in this case, mostly you will find that the differentiation is not being done. That means the value of y is hidden within that, say x squared plus y squared or something like that. So how do we do that? So this comes what is called an implicit differentiation. So we need to differentiate both the sides with respect to x when you differentiate a y term, and we solve dy by dx alone and take alone y. And if we differentiate term which has a y, then we have to need to attach dy by dx in that term. So for example, let us try one example so that things become much clearer. Say for example, we have to find d by dx of 2y squared, right? We are trying to solve with this. So with respect to x, y term, so first using the d by dx formula, what we do is that we find it as 4y, right? Because there is a y term attached to it, see this one, this is y term, this is x term. So now there is a y term attached to it. That means we have to put the dy by dx at the end. I'll just show you another example which will make things clearer. Okay, let me use a different color so that it becomes visible now. Say for example, we are trying to find out the dy by dx. So this part we will just take a note on that. So for example, we are trying to find out the dy by dx, okay, of x squared plus y squared equals to 36, right? X squared plus y squared equals, oops, I'm sorry for this, is equals to 36. Now what is happening over here? You see that this term is basically a kind of an implicit differentiation because the y is included. So first of all, step number one, what we need to do is that we need to find the derivative of x squared. Okay, this part I am taking, this one. So what is the derivative of x squared? Say 2x. Then I take this term, so I put it y squared equals to 2y, right? Now there is a y term, so we need to multiply a dy by dx to this. So what do we do is that we write 2x plus 2y, which is this x squared plus y squared, and then we add a dy by dx to it. So we put over here dy by dx, right? And then we know the constant value, which is 0, right? In order to further solve, what we are doing is that we are subtracting that which is not required, this part, and from this part what I am doing is that we are subtracting both the minus 2x from here, and I am taking out minus 2x from here, right? So what it happens is that this part only remains, so we can further write 2y, right, dy by dx, this is the attached term which is from here, and it equals to minus 2x, right? Clear? So what we can do is that in order to get rid of this 2y which we don't want, we are dividing both sides by 2y. So what I get over here is 2y, right, 2y, then I put this dy by dx over here, okay, and then I write this part, that is minus 2x whole divided by 2y, right? So this part, this will be divided by 2y, right? So now as we take it forward, this part and this part gets cancelled out. So what we are left with is dy by dx equals to minus 2x by minus 2y. To solve things further, we cancel these things out. So what we get from here finally is dy by dx equals to minus x. Right. This one is not, this is, I'm so sorry. This won't be this. Minus 2x by y, because let me check. Minus 2x, yeah, this is 2y, yeah. So it would be minus x by y. So this is our answer. Right. So just to show you, this is actually implicit differentiation. So we are learning the difference between dy by dx and d by dx, but obviously these things come into play, the explicit and implicit. So just note it that when you're getting a kind of an expression like this part, where you are not getting something like y equals to, then you have to use this particular method, right? And you will get the value, and what you need to do is just attach dy by dx once you differentiate the first and the second variables, right? So just to cut things short, I think this part is clear from you. So now, say for example, if we do a kind of a differentiation, say for example, I will just give a very simple example. So say if I write over here, if I write d by dx of x cube, so obviously this one will become equals to 3x squared, right? Then we further write d by dx of say y cube. So we write it as 3y squared. And as because this is again something, this one is x and y which is not matching, which I showed you. So we need to put another term which is the dy by dx, because this is an implicit differentiation. And say for example we introduce another variable, say it can be time, or let us say for example s. We introduce s this time, right? And we need to differentiate with x raised to the power 4. So again you see this one x, it is not matching, so it is an implicit differentiation. So this would be 5x4, 5 minus 1 4, and then we can differentiate. You have to put dx by what would be the next term, obviously the second one which we are differentiating, that is ds, this term and this term. So now you see that we can differentiate with respect to anything. We are differentiate with respect to x, we differentiate with respect to this time we are differentiating this one, and we are differentiating with respect to s. So and we can even differentiate with respect to t also, like if you want we can use it like something like this, which would be differentiating with respect to time. So we can put it like d by dt, and we can put it further as x5, and what we can get over here is so it would be this one, this I'm so sorry, this is 5, this one is 5, I'm so sorry for this, so that is why. So if I get it say for example x to the power raised 4, so we would get a differentiated value of f 4x 4 minus 1 3, and then we would put the term dx by dt and further on, right? So we can differentiate with respect to anything, x, s, t, whatever. But as you understand that now that we have gone through all those examples, it becomes clearer that why we are using the d by dx. D by dx we are using in order to know that this is basically an operator. Now you see, if I just want to summarize the entire video, so here you see that dy by dx is, we are taking a derivative of y with respect to x, where d by dx is just an operator. When we say this is an operator, what we are trying to tell is that operator means that we are doing the entire operation based on this, right? So I will just show you the final summary, which will bring everything in a nutshell. So let me remove this part, and here comes the summary. So I'll just make a quick note on this. So d by dx means differentiate with respect to x. This is the first point. dy by dx means differentiate y with respect to x. d by dx expresses a command, obviously, like do this, do the derivative. And dy by dx tells us what to do, like it is a kind of a statement. So you see in the point number 5, which I have written, that d by dx is used as an operator. d by dx is an operator. It tells us to differentiate with respect to x, whereas dy by dx represents a mathematical expression where differentiation with respect to y, this has already occurred. That means this is just a kind of a statement where it is saying that this has already happened, and d by dx is basically an operator. Also note that what I have written, d by dx is a verb. Let me put this line so that you understand. Yep. So this is a kind of a verb. That means it is an action which needs to be done, right? Whereas d by dx is actually a noun. That means it is in respect to what has actually happened. I hope this clears up all the things that that was ruling in somebody's mind in order to know the differentiation part, what the difference and things have been. So here is, I hope you liked it. So that was my basic objective, to let you know the difference between d by dx and dy by dx, because this comes too often. This is a kind of a nice summary which you can just keep a note on this, like what actually would summarize that it means to a kind of a command where these are actually the statement. I hope you like this video. So d by dx I have used in the further differentiation rules, so you can just check out. I will just put a few links in my comment section. Do like and comment, and do let me know if you feel comfortable, or is it fine, or you have further suggestions in order to improve this video, or if you want to make any video from your side. Thank you very much. Stay safe, stay happy. Do like and subscribe, and have a nice day. Bye.